Hello and welcome. This video will be an introduction and overview of VCS. VCS is a vector-based tool to simulate experiences such as roller coasters and attractions. When you open the program for the first time, you will see the welcome window, which has a link to our support page. The program is made up of three main sections. The first is the menu bar, which has functions you would expect, such as save, save as, and export. Next is the action tabs, which include the builder and the editor. The builder tab includes the main features to get started with the program. You may select one of two options to start your program. The local anchor is used to simulate attractions such as roller coasters. The global anchor mode is used to simulate attractions such as rides. In the editor tab, you will find the main functions to edit a program. On the left is the editing section. In the middle is the selection section, and on the right will be the plot, which is currently not shown. Before you get started with the program, you'll need to set a few properties in the properties window, including gravity, property unit, which is the precision for properties, length unit, which is how much distance is between each calculated unit, R1 angle, R1 offset, which sets the force track offset, R2 angle, and R2 offset, which sets the track 2 properties. Lastly is the radius limit, which sets the ceiling for the radius. All of these will be discussed and shown in further videos, but for now, I recommend to change the R1 and R2 angle to 160 degrees and 200 degrees, and the R1 and R2 offset to 1, and the radius limit to 50. Once a mode has been selected, you will need to add the starting properties, which include the origin, which has the position and friction properties. In the editor, you may begin selecting, adding, or removing sections of the program. One important concept I want to cover is functions and how they are used in the editor. Functions determine the outputted value based on the inputted parameters. Starting from the top to the bottom, the change type determines the outputted value on the y-axis. This can be force or radius, for instance. The change chart determines where the function starts on the y-axis. The change value determines how the function output changes over the distance. The length type determines how the function output changes over the x-axis. This can include time and distance, for instance. The length value determines how long the function runs. The calculation determines how the output changes over the distance. A linear output will create a straight line. A squared output will create a curved line. A cubed function will create an S-shaped line, and a quartic output will create a U-shaped line. The degree value determines how quickly the function changes over the distance. A higher degree will result in a quicker change. Lastly, the inverse function is only available for the squared calculation, and this flips the output. The concepts we have covered will be enough to get you started on the program and will be used further in future videos. In the next video, I will be covering the local anchor mode, and I hope to catch you then.